the world's 10 most powerful engines. A 4,000 horsepower mining truck is only at the bottom of the list, while the number one makes a 2-hour trip around the globe a reality. In the pinnacle of human industrial civilization, engines have always been the ultimate measure of a nation's strength. Entering the 21st century, the field of engines is undergoing an epic transformation. From the king of single-engine thrust, the rocket engine that creates a 15 million-pound earthquake upon ignition, to the game-changer in aerial combat that allows for mid-air stationary turns and inverted attacks, the core of the F-22 Raptor. There's even the detonation engine, awakened in the lab as traditional turbofans approach their physical limits, pushing flight speeds to Mach 16. From air combat to the deep oceans, from the Earth's core to the heavens, these powerful souls forged from steel roar with humanity's ambition to conquer the limits. In this episode, let's explore the 10 most powerful engines on Earth, each one more stunning than the last. We look forward to your subscription and likes. Number 10, the CAT 797F mining truck engine. If an F1 car is the cheetah of the speed world, then the CAT 797F is the Tyrannosaurus Rex of the engineering machinery world. The heart of this steel beast is a diesel engine capable of producing over 4,000 horsepower, equivalent to the combined power of 10 Ferraris. It wasn't born to chase speed, but to conquer the harshest environments on Earth for tasks like coal transportation. It can haul over 400 tons of ore through high-temperature, dusty mining areas, roaring forward without complaint. But don't think it's just a clumsy brute. It's also very smart. The engine uses a high-pressure common rail, fuel system, and multi-stage turbocharging technology. This means that even under a full load, it can precisely control fuel injection, achieving both explosive power and fuel efficiency. Compared to the previous generation, this engine's fuel efficiency at the same power output has increased by over 10%. The money saved on fuel in just one day of operation is enough to treat a maintenance crew to several lavish meals. This engine is not only powerful, but also extremely reliable. While other engines might fail in high altitude or extremely cold environments, the CAT 797F's power unit can operate continuously for hundreds of hours without breaking down in temperatures ranging from -40 to 50 degrees Celsius. Like a tireless miner, it was designed to transport treasures from deep within the Earth's crust, day and night. Globally, the CAT 797F is widely used in copper mines in South America, iron ore mines in Australia, and large coal mines in Inner Mongolia, China. There, it operates for more than 20 hours a day, with an average annual working time exceeding 7,000 hours. It is truly the backbone of the world's heavy mining transport industry. The engine of the CAT 797F doesn't fly into the sky or dive into the deep sea, but it keeps the industrial foundations of the world running. Every roar is a testament to its power and reliability, safeguarding the heavyweight engineering projects of human civilization. Number 9, the Turbomeca Ariel 2D turboshaft engine. Helicopter flight has always held a special significance. It doesn't pursue the extreme speeds of a fighter jet, nor does it carry hundreds of passengers on long journeys. The charm of a helicopter lies in its agility, precision, and reliability. And behind all of this, a powerful heart is essential. The Ariel 2D is not the bulky, noisy, old-fashioned machine you might imagine. It's compact, weighing just over 200 kilograms, yet can deliver up to 950 shaft horsepower, enough to lift a 2-ton helicopter and make it spin with ease. It's like a skilled martial arts master, small in stature, but swift and lethal in every move. The engine features a single-shaft free turbine architecture and integrates a full authority digital engine control system, or FADEC. This system precisely controls fuel injection and compressor ratio, ensuring stable power output under all flight conditions. Whether in scorching heat or at high altitudes over 3,000 meters, it starts reliably and never fails. Compared to the older generation, the 2D version has 10% lower maintenance costs and a 25% longer lifespan, meaning safer flights and easier maintenance. You might be surprised by how widely this engine is used. From China's KJ-500 early warning helicopter to civilian rescue helicopters like the EC-145 and H-125, even crews performing rescue missions on the Tibetan Plateau rely on this engine. It's hailed as the world's most reliable medium-sized turboshaft engine, with over 15 million accumulated flight hours and a negligible accident rate. The Ariel 2D isn't a flashy star, but a respected unsung hero. It powers countless emergency rescues, forest firefighting missions, border patrols, and earthquake relief operations. In the skies you don't see, it is always silently standing guard. Number 8. The GE9X engine. If commercial aviation engines were in a heavyweight boxing championship, the GE9X would be the super beast that could knock out the wind with a single punch. Each GE9X can generate up to 134,000 pounds of thrust, like unleashing the power of more than a dozen large trucks simultaneously. It's not only one of the most powerful turbofan engines in commercial aviation, but also a benchmark for fuel efficiency and environmental performance. This engine features a massive 134-inch fan, with a diameter larger than the fuselage of a Boeing 737. It has only 16 fan blades, which, compared to the GE90 series, reduces drag and improves airflow efficiency. This design reduces the engine's weight while maximizing airflow intake, boosting both power and efficiency. It's worth noting that the GE9X's fuel efficiency is 10% better than its predecessor, the GE90-115B. Compared to other wide-body aircraft engines, it achieves about 5% better thrust and fuel consumption efficiency. In an airline's operating costs, where fuel accounts for about 20%, this translates to significant savings. Another key advantage is its use of advanced materials. The engine utilizes ceramic matrix composites, CMCs, for the combustor and turbine blades, providing high-temperature durability. These materials are 1/3 lighter than traditional alloys, yet can withstand temperatures of up to 1,315 degrees Celsius. Furthermore, its overall pressure ratio is as high as 60-1, nearly 50% higher than the GE90, which significantly improves combustion efficiency. During testing, the first GE9X completed 167 hours of ground tests, 213 cycles, and 89 starts, collecting over 1,200 critical data streams. The results showed that its performance, thermal characteristics, and mechanical structure met all expectations. The engine also underwent simulated tests in extreme environments, including hail, dust, rain, and snow, to evaluate its reliability. In contrast, common engines like the GE CF6 or CFM56 typically have thrust between 40,000 and 60,000 pounds, suitable for short to medium-haul flights. The GE9X, while much larger, achieves higher thrust, lower fuel consumption, and less noise, and is capable of supporting the world's longest flight routes. Number 7. The MAN B&W 12 V4860 diesel engine. You may not have heard of the MAN B&W 12 V4860, a name that sounds like a secret code, but it is the heartbeat of one of the quietest yet most powerful giants on this planet. A large portion of the cell phones, clothes, coffee, and even the small gadgets in your packages are delivered from across the ocean by engines just like this one. It doesn't fly like an airplane or race like a sports car. Its mission is to pull tens of thousands of tons of cargo, crossing oceans day and night. It's like a silent sea yak, incredibly strong but never showing off. How big is the cylinder of this diesel engine? A single cylinder has a diameter of 48 centimeters, wider than the largest wok in your kitchen. If you stood on the edge of the cylinder liner, you might think you were in a boiler factory. Its single engine power can reach 20,000 horsepower, equivalent to 200 tanks firing up at once. Yet, it silently moves the lifeblood of global trade with a low-speed heartbeat of just over 500 revolutions per minute. Interestingly, many of China's flagship products are associated with it. For example, a 200,000-ton cargo ship under COSCO Shipping, the COSCO Shipping Aries, is equipped with a MAN Series main engine. It departs from Qingdao, carrying domestically produced new energy vehicles and home appliances to Africa, Europe, and the Middle East. It has run continuously for over 100 days in the hot waters of the Middle East with zero mechanical failures. Chinese crew members joke that it can stay up later than they can. This engine burns heavy oil, consuming hundreds of liters per hour, but its energy consumption per unit is very low. Transporting 1 ton of cargo from Tianjin to Rotterdam consumes less energy on average than taking a high-speed train. Chinese shipyards, such as Hudong Zhonghua and GCS, have long been licensed by MAN to independently assemble, tune, and maintain these behemoths. They are not only technologically sound, but also affordable and durable. Number 6. The M1 Abrams AGT 1500 turbine engine. If the CAT 797F is the muscle car of the engineering world, then the AGT 1500 turbine engine used in the M1 Abrams is the jet engine of the armored vehicle world. While other tanks slowly chug along with diesel engines, the U.S. military took a different path, equipping its main battle tank with an aviation-grade gas turbine. You heard that right. It's an engine similar to what you'd find in a helicopter. Some U.S. soldiers even joke that they can barbecue meat behind their tanks. The AGT 1500 has a maximum output of about 1,500 horsepower, allowing the 62-ton Abrams tank to accelerate from 0 to 32 kilometers per hour in just 7 seconds. For a tank, that's practically taking off. Its power-to-weight ratio and response speed are far superior to conventional diesel engines. On the battlefield, it can move and charge on command, like a fire-breathing beast always ready to pounce. Even more incredibly, it is compatible with multiple fuels, including diesel, jet fuel, gasoline, and even alcohol blends, making it a true steel beast that won't starve. This is particularly important in complex battlefield environments with unstable supply lines. However, this steel heart has its quirks. It's extremely thirsty, with a fuel consumption per kilometer nearly double that of a diesel engine, which significantly increases the logistical pressure on the U.S. military. The price for enhanced battlefield mobility is burning through cash. It's said that during operations in Iraq, the U.S. military had more fuel tankers than tanks. In comparison, China's main battle tanks like the Type 99A still use diesel engines, but have made continuous breakthroughs in high power and reliability in recent years. The latest domestic 1,500 horsepower diesel power system has a thermal efficiency close to the AGT 1500, and it's more fuel efficient and easier to maintain. But one must admit, the U.S. military's AGT 1500 was a mechanically bold and highly representative experiment in the history of military engines. Number 5. The Raptor rocket engine. On Earth, it looks like a giant steel octopus, but in space, it's a true fire dragon. The Raptor rocket engine is the next-generation propulsion system built by SpaceX for its Starship, and it can be said to be the most powerful engine for humanity to leave Earth and land on Mars. Raptor uses the most advanced full-flow, staged combustion cycle technology. The name sounds complicated, but you can think of it as squeezing every last drop of energy from the rocket fuel, making it incredibly efficient. In contrast, traditional rocket engines, like the Soviet-era RD-180 or the American RS-25, only pre-burn a portion of the fuel, which compromises thermal efficiency and thrust density. Raptor uses methane and liquid oxygen as its fuel combination, which has two advantages. First, methane is easier to store and more stable than hydrogen, and it's less likely to cause engine icing or corrosion. Second, if we land on Mars in the future, methane can be synthesized on-site. This means SpaceX's Starship has the potential to refuel for its return journey. So how powerful is it? The Raptor sea-level thrust is about 2 meganewtons, more than double that of SpaceX's older Merlin engine. In a vacuum, its thrust can reach 2.3 meganewtons. It is lighter and smaller than the Saturn V's main F1 engine, yet more efficient. More importantly, Raptor is designed to be reusable and support rapid refurbishment. This means future rockets will no longer be disposable commodities, but can take off, land, and take off again like an airplane. This revolutionary business model is SpaceX's secret weapon to win the future space race. In tests, the Raptor's exhaust temperature exceeded 3,300 degrees Celsius, with an exhaust velocity of 3.5 kilometers per second. The engine chamber withstands pressure over 300 times that of the atmosphere. This is an extreme challenge for any material and manufacturing process, but SpaceX, relying on 3D printing and extreme cooling technology, has brought this space beast from paper to the test stand. Number 4, the F1 rocket engine. If there is an undisputed king of thrust in the history of aerospace, the F1 rocket engine is like an insurmountable, towering peak. Its thrust once shook the entire planet. Speaking of the F1, don't be fooled by its simple name. It's a superstar in human spaceflight history. It was the workhorse of the Apollo program, shouldering the heavy responsibility of sending humans to the moon. Can you imagine how powerful the thrust generated by this engine was? Its power was enough to lift 15 Boeing 747s at the same time. The roar was deafening. A full 15 million pounds of thrust propelled the Saturn V rocket, breaking through Earth's atmosphere. That moment was like the Earth letting out a roar, declaring humanity's determination to conquer space. The F1 engine's nozzle was a full 3.7 meters in diameter. The nozzle exit alone was as large as a small living room, big enough for an adult to crawl into. Inside the combustion chamber, the flames from the injected fuel reached temperatures as high as 3,300 degrees Celsius, hotter than the surface of the sun. The engine used liquid oxygen and high-purity kerosene as fuel, achieving extremely high combustion efficiency. Its turbopump could deliver over 2,500 kilograms of fuel per second, ensuring the engine fired continuously. This engine weighed 8,400 kilograms, equivalent to a small truck, yet it could concentrate a force of 6,700 kilonewtons. This wasn't just a machine, it was the crystallization of human courage and wisdom of that era. It carried the dreams of astronauts and supported humanity's steps in exploration. In 1969, thanks to the combined effort of 5 F1 engines, the Saturn V rocket successfully sent Apollo 11 to the moon, completing the first manned lunar landing in history. To this day, the F1 remains the world's most powerful single-chamber liquid propellant rocket engine. Its design philosophy was simple and efficient, yet its manufacturing was exquisitely complex. It is still referenced in aerospace engine design today. When developing its new generation of heavy-lift rockets, NASA still draws upon the technical experience of the F1. The F1 engine is like the heart of a giant, its power driving the progress of human civilization. It showed us that the bigger the dream, the stronger the power. Number 3, the F-135 engine. The F-135 is a super engine tailor-made by Pratt & Whitney for the F-35 Joint Strike Fighter. Don't let the name fool you. It's a leader in modern fighter jet propulsion. Its B variant, in particular, with its unique design, achieved supersonic vertical takeoff and landing for the world's first stealth fighter. Its maximum thrust exceeds 43,000 pounds, equivalent to the force of 10 adult African elephants charging simultaneously. This thrust allows the F-35 to easily reach speeds of Mach 1.6, far exceeding conventional jet aircraft. One of its biggest highlights is its thrust vectoring control system. By adjusting the nozzle's direction, combined with the lift fan in the fuselage, the F-135B can achieve vertical takeoff and landing in almost zero space. This allows the F-35B to take off from aircraft carrier decks or even confined urban environments, greatly enhancing operational flexibility. This capability is currently unique in the world, breaking the limitation of traditional jet engines that rely on long runways. Vertical takeoff and landing present extreme technical challenges for an engine. The F-135B uses advanced heat-resistant materials and efficient cooling systems, allowing it to withstand extreme temperatures of over 1,500 degrees Celsius in the combustion chamber, ensuring stable operation under extreme conditions. This engine is like a beast of steel, both powerful and reliable. In addition to its powerful thrust and excellent heat resistance, the F-135 also shows significant improvements in fuel efficiency. Compared to the F-119 engine used in the previous generation of fighters, the F-135 improves fuel efficiency by about 10% through optimized combustion and airflow management. This allows the F-35 to stay in the air longer, perform longer-range missions, reduce refueling frequency, and greatly enhance its battlefield endurance. Number 2. The F-119 PW-100 engine. This is the power system designed by Pratt & Whitney for the F-22 Raptor fighter. It represents the forefront of modern fighter engine technology, with outstanding thrust and incredible maneuverability. It is the core of what makes the F-22 the world's most powerful stealth fighter. With a maximum thrust of over 35,000 pounds, the F-119 not only allows the F-22 to break the sound barrier, but also supports supercruise. But unlike the F-135, the F-119 emphasizes efficient supersonic capability, allowing it to maintain stable cruise at supersonic speeds without using the afterburner, extending combat time and reducing fuel consumption. This design enables the F-22 to conduct sustained long-range cruise missions, ensuring it can penetrate target areas without being detected by enemy air defense systems. However, the true essence of the F-119 lies in its thrust vectoring control system. Unlike the F-135's vertical takeoff and landing, the F-119's thrust vectoring system is specifically designed to enhance maneuverability. It allows the F-22 to perform extreme maneuvers in the air. Pilots can adjust the nozzle direction to make the fighter perform sharp turns, sudden stops, and even fly inverted at high speeds. This supermaneuverability gives the F-22 a significant advantage in air combat, allowing it to attack or evade enemy aircraft in the most unpredictable ways. Furthermore, compared to traditional turbojet engines, the F-119's turbofan design provides more power with lower fuel consumption, allowing the F-22 to maintain combat capability for longer periods during high-intensity operations. The F-119 PW-100 is the perfect balance between thrust and efficiency for a modern fighter, and it's key to the F-22's supersonic combat advantage. In summary, the F-119 engine is not just the power source for the F-22 Raptor. It's a breakthrough in air combat maneuverability. It lacks the F-135's vertical takeoff and landing capability, but possesses far superior aerial agility. In high-altitude dogfights, it demonstrates unparalleled flexibility and reaction speed through its thrust vectoring technology. Number 1. The detonation engine. If the F-135 is the precision heart of a fighter and the F-119 is the sharp blade of aerial maneuverability, then the detonation engine is the nuclear-level existence in aircraft propulsion systems. The shock and innovation of this engine make traditional turbofan and turbojet engines seem pale in comparison. In front of it, the F-135 and F-119 are mere juniors. Recently, Some sensational reports from foreign media have caused a stir in the global aerospace community. China develops Mach 16 miracle engine, 12,250 miles per hour, circle the globe in 2 hours. These headlines made people feel like they had entered a sci-fi world, thrilling many, but also raising doubts. Is this real? What real breakthroughs are hidden behind these exaggerated numbers? In reality, the so-called Mach 16 dual-mode engine has not been fully realized as reported. It was just a misinterpretation and exaggeration of several Chinese research achievements. The real breakthrough was a successful ground test of an oblique detonation engine conducted by teams from the China Aerospace Science and Technology Corporation and Northwestern Polytechnical University. This technological breakthrough is of extraordinary significance for future hypersonic aircraft and weapon systems. What's most surprising is that this engine uses aviation kerosene, not traditional hydrogen. While hydrogen provides extremely high energy, its storage and transportation are very difficult, limiting its practical application. Aviation kerosene, being a common and mature fuel, means this new type of engine has the potential for wide practical application. It has enormous potential, especially for the rapid response of hypersonic and military aircraft. Another breakthrough is that the engine ran stably for more than 2 seconds during the test. While this may not seem long in conventional terms, in the hypersonic field, it is an extremely important achievement. The detonation combustion process is no longer a fleeting explosion, but a continuous and stable release of energy. This provides the possibility for long-term stable operation of an aircraft. This breakthrough means that future hypersonic aircraft will no longer be limited by the short duration of instantaneous detonation combustion, but can maintain efficient operation for longer periods. Although the United States started earlier in the hypersonic field, many of its technologies are still in the laboratory stage and have not yet been put into practical use. If the U.S. truly held a leading position in the hypersonic field, it probably wouldn't be so low-key. China's rapid rise in this field is not only eye-catching in terms of technological breakthroughs, but has also achieved significant results in practical application. Although China's detonation engine technology is still in the initial experimental stage, with continuous development and improvement, we can foresee that detonation engines will become one of the core power systems for hypersonic aircraft in the future. With the continuous advancement of technology, future aircraft, powered by detonation engines, will cross the globe in just a few hours and may even open up the possibility of traveling to Mars or other planets. Of these 10 most powerful engines in the world, which one shocked you the most? Let me know in the comments. Remember to subscribe, like, and share. Global Superlatives updates daily. See you tomorrow.